Oh, hey, thanks for stopping by my virtual exhibit here for Virtual VCF West. Hope you're enjoying the show so far. And I really hope that next year we'll be back in Mountain View so that you can actually touch and feel these things. But for now, we do what we do. I call this the Nova 445. And so what's that? Well, it's a homebrew retro microcomputer, I guess you'd call it, that emulates a Data General Nova computer. Now the Nova was a line of mini computers that Data General Corporation created, first introduced in 1969. 16-bit microprocessor, not a microprocessor, 16-bit mini computer. And then in the late 70s, Fairchild, which had a microprocessor division in Mountain View, came out with basically a Nova processor on a chip. This is the second generation, the 9445. The original was the 9440, which was also known as the Microflame. I think they dropped that designation when they came out with the 9445. But there it is. The interesting thing about the 9445 is it uses integrated injection logic, which is a high-speed bipolar technology, whereas everybody else pretty much was using NMOS at that time. So speed-wise, by comparison, there's the Fairchild chip, and here's a Zilog Z8000 from approximately the same era. This has a 1984 date code on it, and it runs at 6 megahertz. The Fairchild processor runs at 20 megahertz. So that's pretty cool. Oh, and of course, the Nova was the first computer I used and learned to program on and such. So it has a special significance to me. So one of the reasons that I chose to do this project. I'm showing it to you today as a work in progress. The full design has additional functionality, which I haven't implemented yet. This is specifically a real-time clock, a serial terminal interface, and a disk emulator. We don't have any of that right now. What we have is a processor and memory and some I/O decoding and a graphics board. So we can run code out of ROM, and we can display on this screen here. And that's about all it does. There's really no input device right now. It generates a standard NTSC video signal, which is displayed on a high-resolution monochrome monitor. We're getting 480 pixels by 240 lines of resolution, 240 vertical lines, 480 horizontal lines. And then there's also a minimal front panel here, if you want to call that a front panel. There's a connector that you can see, and which would allow for a full switches and blinking lights front panel. But for now, it's a minimal thing which just lets me reset the processor and start the code running. Code is in ROM, which is on this lower board, which you can't see right now. I'll put pictures of the individual boards on the screen so you can see them. Now, if you've been to the last two VCF Wests and you've dropped by my exhibits, you're thinking, oh, well, the demo's going to be TacoBot. But no, it's not. For two reasons. One, I already told you, I don't have an input device on this, although it would be easy enough to implement one. And two is that TacoBot is best experienced up close and personal, so where you can touch it and feel it and see it. We lost John Conway this year to COVID virus, and so I thought it would be appropriate to implement Conway's Game of Life as the demo to honor him. So I've done a rather naive implementation of and unoptimized implementation of the life game here, and it takes I'm going to start this up here. It takes about 210. It didn't start. I said I'm going to start. I said, there it is. Okay. Work in progress, folks. Anyway, it takes about 210 microseconds to compute each cell, which doesn't sound so bad until you realize that there's 113,764 cells, 480 minus 2 because of the outline, by 238. That's over 113,000. So it takes about 24 seconds to compute each generation of the game. And so it's going to tick along very slowly here. But what we'll do is I'll speed it up. I'll speed up the video so that you can see several generations going by. And as the game runs here at higher than actual speed, and the cells begin to learn about social distancing, I'll say once again that I hope that we can do this live and in person again next year in Mountain View. And I'll hope to have the completed computer done at that time. And I'm hoping to have it running Data General's RDOS operating system, which will be fun. In the meantime, if you're interested, you can follow my build progress on my YouTube channel, which is called Martian Tech. I'll put that up on the screen there so you can see, and I'll have updates as I go along to let you know how things are going.